The omega-3 story really started in the 70s with cardiovascular disease. The omega-3s were really shown to do a variety of things. One is they lower levels of one of the blood fats called triglycerides, and lowering levels of that is good for heart health. The omega-3s seem to lift up the parasympathetic and shift sympathetic down so that it's reflected in a slower heartbeat. And finally, the omega-3s are anti-inflammatory, and that has widespread effects on not just cardiovascular disease, just about any disease. Dr. Ben Watson has come to the conclusion that a low level of C15 in the diet has lots of bad health consequences. And the one study that I'm aware of that given C15 in the doses recommended by the manufacturer had the unfortunate outcome of half the people that got the C15 didn't even see an increase in blood C15 levels. And the half that did really didn't get any significant metabolic health effects from it. And I personally think that the marketing has far outpaced the science here. I kind of see omega-6 and omega-3 as partners in good health. We know that people who have the highest omega-3 levels have the slowest rate of loss of telomeres. So it means their cells are turning over less fast, they're living longer, which manifests in a longer lifespan of the whole organism.
Bill, how big of an issue is omega-3 insufficiency in the modern world?
Well, I think it's huge. It's one of the few things we can do a lot about very easily and cheaply and safely.
How does somebody know if they fall into that camp?
Test their blood level of omega-3. Test their omega-3 index.
Well, let's talk more about that. OmegaQuant, omega-3 index. What does this testing look like? And how often should somebody have it done?
Sure. So the test that I'm referring to is called the omega-3 index. It's a test that we developed, actually published our first paper on in 2004, so it's a little over 20 years old now. The test measures the amount of EPA and DHA, the two marine or fish-based omega-3 fatty acids, the level of EPA and DHA in red blood cell membranes. And we like to focus on red cell membranes instead of plasma or serum, which some other tests use, primarily because the red blood cell is the easiest blood cell, the cell of the body to get to. All the omega-3s throughout the body live in the membranes. And so we like to measure a membrane level as a representative of other tissues in the body. And it's very much like the hemoglobin A1C for diabetics, or measuring glycemic status. It's a long-term, stable marker. That doesn't change radically throughout the day, throughout the week. It's very steady. And that's exactly what you want to have, is a good long-term look at status. The fact that it's measured in a red blood cell, it's expressed as a percent, or a couple of other reasons why it's kind of like the hemoglobin A1C. It's a percent. EPA and DHA is a percent of the total fatty acids in the red cell. So EPA and DHA typically will run from a low end of maybe 3% of the total fatty acids up to maybe 12% of the total fatty acids. It's quite a range. We think the sweet spot is 8% to 12%. That's what most of our research points to as being the best place to be, and it's a practical place to be. Can be done with food or with supplements. That intermediate zone, somewhere between 4 and 8%, is obviously a better place than 4 and not quite as good as 8. But it's a continuum. There's no magic cliff you fall off of when you hit 4, or a wall you hit it at 8. It's the higher the better, to a point. So this test is done can be done on a dried blood spot that can be collected at home with a finger stick, simply mailed into OmegaQuant, the laboratory. And after, I think about 5 days after the test arrives in the lab, you get a result back by email, and tells you what your omega-3 index is, and gives you an idea of how much omega-3 you need to increase in your diet in order to get up to that 8%.
The average person not supplementing with an omega-3, having this test done, how often would you say they fall between that 4 and 8%?
The average American, roughly, based on large population studies we've done in the U.S., 5% is pretty typical. 5, maybe 5.5. About maybe 5% of people are over 8%. at baseline. And I can't say those are people that are not supplementing. These are just, again, a large population. Some of them would be supplementing. And the people who tend to be under 4%, the lowest level, the two groups we've studied that we've seen that, one is American vegans, and the other is American military personnel deployed in Iraq. So unfortunately, they both are around 3.5% omega-3 index, which is, it's terrible for the service people who need higher omega-3s for all kinds of good reasons. And I won't say it's terrible for the vegans because I don't really know that. They have a lot of other health behaviors that can be very beneficial, and whether having that low omega-3 because they eat no animal products, and EPA and DHA only come from animal products, that is fish. Now you can get algal forms of EPA and DHA as supplements, and vegans certainly can do that, and they work just fine. But in any event, there's a lot more research to be done, I think, in the vegan omega-3 and health question. But that's kind of the range. The people who are at the upper end of the level are people eating a lot of fish, logically. And around the world, we see high levels of omega-3 in cultures that eat a lot of fish, like the Japanese, which is one of the kind of the classic. Their average omega-3 index is like 9 to 10%. So about twice as high as the average Westerner in the US or in Europe.
Once somebody has their baseline, how often do you recommend retesting?
Once you get the baseline and then you make a change, it won't change if you don't change, okay? It's pretty steady. Once you say you come in at 5% and you say you want to get up to 8%, you will increase your omega-3 intake. We can talk about that in a minute, how much you should go for, but it tests about 3 or 4 months later. That's about how long it takes all the red blood cells to be replaced. And so you're really at a new steady state. 3 months is pretty good. 4 months is when all the red cells are replaced, but 90% of the job is done by 3 months. So about that frequently. You don't need to test every week there's no point in that. But you should test, maybe 2-3 times a year once you're in a steady state.
Somebody trying to get to that optimal state in that range, what kind of dosage is typically required? And obviously it's not perfectly clean because we have dietary source plus supplementing if somebody's going to supplement. Mm-hmm. But just as a general ballpark, what does that look like?
Yeah, we have we did a study several years ago where we pooled lots of data from 14 different trials, I think, where we knew what the dose of omega-3 was, and we knew what their omega-3 index at baseline was and after treatment. And so from that, we were able to create an equation that would predict how much EPA and DHA you would need to go from a low omega-3 index up to, say, 8%. That's the target we're aiming for. And so we found, and there's a calculator on our website at OmegaQuant.com. There's a thing called the omega-3 index calculator. And you can click on that, and what you do is you put in your current omega-3 index. Say you put in 5, it's 5%, and it will automatically give you how many milligrams of EPA and DHA you need to get on average. As you point out, it varies by a lot of factors, but a good place to start. And that would be around a gram a day. If you're starting on 4% instead of 5%, you need about 1,500 milligrams a day of EPA and DHA combined.
And you yourself, I'm assuming you test periodically. What number do you typically hover around?
Around 10.
What about
I take about 1,500 milligrams a day and have been doing that for a long time. And so that's kind of where I'm settled in at.
What's the highest you've seen?
Well, we saw one person had a level higher than dolphins had, for crying out loud. She was at 21%. Studies we've done in dolphins with SeaWorld, they're 19%. Of course, fish is all they eat. So it's pretty amazing that this lady, still don't know why. She's not a big fish eater. It wasn't really clear what was going on there. But in any event, once you're at 8, 9, 10%, you're in a very rarefied group. We've, not uncommonly seen 15%, 11, 12, 14, because we do a lot of samples. But at this point, I couldn't say that that's better than being at 10%. There has to be some point of diminishing returns here where, you've done all you can do. And I'm not sure where that number is, but I do know that getting up in that somewhere between 8 and 12% is really seems like the best place from all kinds of health outcome point of view.
Anybody hovering, say, in the high teens, or even all the way up to that one lady at 21, any issues you've seen, somebody going too high and pushing it too far? And the one thing you see more in layman's terms is blood thinning.
Yep.
So have you seen that or other issues? Somebody that gets overly ambitious and starts upping their dosages?
Yeah, it's hard to say because we at OmegaQuant as the lab, we don't necessarily hear about somebody saying, "Oh, I'm having nosebleeds now, I can't stop," which would be a blood thinning issue. That is the most common concern about omega-3s in more the lay press, I'd say. But from the evidence we've published and other people have published, there really is no increased risk for what we would call clinically significant bleeding. You may bruise a little more. That's not considered clinically significant bleeding. It's not hemorrhaging with higher omega-3. But even the FDA on the warning label for the omega-3 drugs, which are dosed at 3 to 4 grams a day, say that there's no increased risk for clinically significant bleeding. And even if you're on a blood thinner, the studies have not shown increased risk for bleeding. So it's not something I think people need to worry about from a health risk point of view.
You mentioned this one lady who got above 20. I believe you said she wasn't even consuming a lot of fish or fish products, which brings up for me individual variability.
Yes.
How much of a difference do you notice person to person when they start supplementing or upping their fish intake?
Wow. I mean, it's an important question. And when we've looked at, we've done dose response studies in different groups of people. And I remember this one group that was getting 1,800 milligrams of EPA and DHA a day. About 25 healthy volunteers just got randomized into that, 1,800 milligram group. 5 months later, the change in the omega-3 index range, what was it? I mean, it was a nice change. It went from about 4 up to about 9, 8 or 9, which is good. What you'd expect. But some, 1 or 2 people were down there and it only changed 1 or 2 points. Other people changed 8 or 9 points. And it's baffling to me. I don't know why there is such a variability in response to the same dose of omega-3, but it just underlies your point. There's biochemical individuality. Each one of us is, which is a reason for testing. There are certain things you shouldn't do if you want to absorb omega-3 well. You take them with food. That's maybe some people weren't doing that in this study. I think they all were supposed to. Obviously, there are drugs that block fat absorption. Don't take omega-3s with a drug that blocks fat absorption, and that's kind of obvious. But the variables are myriad that might explain why one person goes up a lot and one person goes up a little. That's just the way it is.
Okay, we want to take them with food.
Yep. Let's
dive into specifics of what we want to look for in an omega-3 supplement.
Sure. Well, I guess imagine that you're walking down the aisle and at Costco or a drugstore somewhere, and you're looking at the supplements and here are all these omega-3 things. Some of them say just omega-3, and that could be misleading because it could be just the plant omega-3, alpha-linolenic acid, ALA, that is not a substitute for EPA and DHA. It doesn't do the same things. It's a shorter version of EPA that's very poorly converted in the body up to EPA and DHA. So if you're looking at a bottle, make sure you look at a bottle it's got to at least say something about fish or krill or marine or ocean or something like that. It's got to come from fish. And so you're looking for EPA and DHA, and you're only going to see it typically on the back side, on the back panel of the product. Many products will say 1,000 milligrams on the label, which simply means that the capsule contains 1,000 milligrams of oil, not 1,000 milligrams of EPA and DHA, because EPA and DHA are a subset of the oils in fish oil. The most common, I guess the cheapest versions of omega-3 capsules will have about 30% EPA and DHA, 300 milligrams per 1,000 milligram capsule. So just need to be aware of that. It's nothing wrong with it. It's if you're going to try and take 1,000 or 1,500 milligrams, you're going to be taking, maybe 10, 5, 6, 7 capsules a day, which is a lot. And there are more efficient ways to do it. So look on the back of the panel to see how much EPA and DHA is in the product. And the first thing you look at is not necessarily the EPA and DHA level, but the serving size indicated. So it's usually the top line of that nutrition facts panel. What do they consider a serving? Well, if they consider a serving one pill, then the omega-3 levels that are reported below is how much is in one pill. But if a serving size is 3 pills, then you got to divide those EPA and DHA levels shown on the facts panel by 3 to get how much per capsule. So that's just something people need to look at. I think the other thing to think about is just some people worry about the ratio of EPA to DHA in an omega-3 supplement. I don't get real exercised about that. Whether it's a little rich in EPA or a little richer in DHA, I don't think is hugely important. I think I would definitely get both of them. I mean, I don't think it's smart just to take DHA or just to take EPA when you could take both of them together. That they always come that way in nature and fish. They're always together. So I think there's a good reason to include both of them in the supplement.
Okay. Important that you highlighted the fact that we can't just look at the front of the bottle and see total milligrams. We want to actually see the DHA and EPA. You're saying the ratio there isn't as important, but we want both. When we add those two numbers together, for an average dose for an adult, what number would you look for?
What would I think would be a good omega-3 intake for an adult?
Yeah, if we add up the EPA and DHA on the back of the bottle, what do we want to shoot for?
I think a good place to aim for is 1,000 milligrams. I mean, I think that's, that's 3 of the really cheap pills. That's not outrageous. You can get pills that have higher concentration of omega-3 in them. So you only have to take maybe 1 or 2. But you'll pay more money for them because it costs more for the manufacturer to concentrate the omega-3s more in the pill. But, and if you aim for 1,000 milligrams, you're probably going to hit 500 or 600 milligrams in reality because you'll forget to take them. Yada, 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 it was good. We're working on a project right now trying to look at the worldwide medical literature and see what intake, the dietary intake, this is food primarily, is associated with the lowest risk for cardiovascular disease outcomes. And it seems that it's going to be around 500 to 600 milligrams a day. So I would aim higher than that in the hopes of actually hitting that.
Okay, you mentioned Costco there. How big of a concern is quality? If somebody is going to go out after this, buy Kirkland, go to Costco and get a big Costco-sized bottle of capsules.
Yeah.
You hear about rancidity. Obviously, when it comes to any supplement or food, we want the best quality we can get. There's things like wild-caught, organic. How much do you look at quality?
I try to major in the majors. Quality is important, but if it's going to cost you $3 a pill to get high quality omega-3, and you say, "Well, I can't afford that, so I'm not going to take any," then no. If all of it's going to cost you 50 cents or 25 cents a pill to get maybe not the highest quality, but good enough, the rancidity problem is not a problem. It's not a health problem. If I can just take a quick rabbit trail down a study that really kind of amazed me that was done in Norway on this question of fish oil rancidity. And these investigators, we're going to hit this thing with a sledgehammer. So they designed a study where they took fish oil, normal fish oil out of capsules. They put it in a beaker on the desktop and bubbled oxygen through it, which is an extreme oxidation that never happens in real life. They then, did that for a day or something. It really oxidizes the bejesus out of this stuff, put it back in capsules, and then took two groups of people, randomly gave half of them this oxidized fish oil and the other half the regular stuff before that wasn't oxidized. And then they measured oxidation products in the blood after about 4 to 6 weeks. You couldn't find anything. Nothing showed up. The body handled whatever was there and took care of it, at least from a blood level point of view. Now, that's an extreme case. But I think it makes the point that the very tiny amounts of oxidation you might get, or quote rancidity, is not going to hurt you. And you're really not diminishing. It takes, to get a fishy smell in a fish oil product, it really doesn't even come from the omega-3s breaking down. It comes from other products. But your nose is so incredibly sensitive to these molecules. You can have, 10 molecules of something that's rancid and you can smell it, but it doesn't affect the quality, the EPA and DHA content of the product at all. So, I know different companies want to sell, well, they sell a higher concentrated, purified product and they want to get paid for it. It costs more money. I get that. But I would not get overly concerned about getting the highest quality possible. I don't take Costco product. I take some stuff that we sell from OmegaQuant called Parasol omega-3 fish oil, and that's a good product. But some of the stuff from Costco's, I don't. Just like you hear me trying to say it, I'm just not that concerned about it. I'd rather have people taking something than nothing.
Okay. So oxygen, not a problem. Other variables I can think of, light, temperature.
Mm-hmm.
How do you think about those?
It's just good practice. They all come in opaque bottles, so the light, they should come in an opaque bottle. Light exposure should be reduced. But the gelatin capsule that these things are encapsulated with is completely impervious to oxygen or any other compound getting in there. So I'm not too worried about that. I think it's just wise to keep these things in a cool, dark place, like the label says. You don't have to freeze them. Freezing them is not going to reduce any burping. And that's one way you can kind of tell a perhaps lower quality product is if you get that fishy burp after taking the fish oils. Typically, if you take them with food, you don't get so much of that. Take it on an empty stomach, not a great idea.
Do we know what's happening there with the burps and the lower quality?
Again, some of these other, they may be oxidation products, but they're not oxidations of omega-3. They're oxidation of other molecules in the oil. They get released in the stomach when this capsule dissolves, and they're very volatile. You can smell them. And so if you get a burp of any kind, these things will come up and you'll taste them. And that I think is a general sign of a less than optimally purified product, but it's not a dangerous product. It's just annoying to me.
Do you find there's a difference between liquid and capsules?
You can certainly get a lot more omega-3 in with a liquid. There are a few products that are quite good. They are flavored and deodorized very well, and you really can't taste. I'm pretty sensitive to fish taste. Most of these oils, I can get a little whiff of the omega-3 or the classic fish flavor. So I don't use them. I'm not against them, but I think they've certainly improved a lot over the years. There's some emulsions that are very, very nicely flavored. You can't taste any omega-3 at all or any fish oil at all. And those are good. If you want to get big doses in quickly, liquid oils are the way to do it. No question.
Talk about the difference between ethyl ester and triglyceride forms of fish oils.
Sure. Yeah. The natural, quote, form of an omega-3 of a fish oil is an oil. Oils are synonymous with the word triglyceride. When you think about vegetable oils or olive oil, those are all fundamentally 100% triglyceride. That's the chemical name for it. And what a triglyceride is simply a one molecule that has 3 fatty acids hooked to a 3-carbon backbone called glycerol. Triglycerol. That's where that word comes from. And usually there's one omega-3 attached to a standard fish oil triglyceride, and then 2 non-omega-3, so that's the 30% comes EPA and DHA per gram of fish oil. So triglycerides are the natural form. Another natural form is a phospholipid, which is a similar molecule that just has 2 fatty acids on it, and one of them will be omega-3. That's what you kind of typically associate with krill oil is the phospholipids. But when you're eating salmon, mackerel, herring, whatever, you're getting the omega-3s in mostly a triglyceride form, but some phospholipids too. And that's great. That's very natural. Those are well absorbed. The ethyl ester form is the form that both of the pharmaceutical products, omega-3s, come in. One is called Lovesa, the other one's called Vasipa, but they're both ethyl esters. And so what's an ethyl ester? Well, what the manufacturers do is they take that raw fish oil and they chemically chop off all the fatty acids from off that 3-carbon glycerol backbone, throw away the glycerol, take the fatty acids, and they separate out all the EPA and DHA using certain chemical techniques. And then they hook the EPA and DHA back up to an ethanol molecule. Ethanol is alcohol. And that produces a very focused. You can now have just a 2-carbon, ethanol is a 2-carbon molecule stuck on the end of a fatty acid. And you can concentrate in one pill a lot more omega-3 that way without taking up space with those other fatty acids. So that's the ethyl ester. It's not as well absorbed, particularly in an empty stomach. It's very poorly absorbed in an empty stomach. So the ethyl esters really need to be taken with food for better absorption. But the triglyceride form is probably the best absorbed form. There's also a form you see out now. They're called restructured triglycerides, or sometimes reesterified. And those are in a triglyceride form, but what the manufacturer has done is after they chop off all the fatty acids from that glycerol backbone, they isolate the omega-3s, and then they hook them back up to not ethanol to make an ethyl ester, but hook it back up to a glycerol, a 3-carbon unit. And so you get a triglyceride that's got 3 fatty acids that are all omega-3 on it, which is not natural, never comes that way, but it is a more concentrated way to get omega-3 in a triglyceride form. So you'll pay more for those kind of products, but they're great. They're fine. They work very well.
What do you think about the difference between these pharmaceutical grade ones versus something you'd find at the health food store? Somebody comes to you saying, which one should I take?
Well, you can't get the pharmaceutical grades unless the doctor writes a script for it. Okay. So that's one thing. You can't just go buy them off the shelf. Although you can buy, particularly online, you can buy dietary supplement omega-3s, not pharmaceutical products. I mean, people talk about their product, their dietary supplement being pharmaceutical grade, which is a little bit of a fuzzy definition. It just means highly concentrated, and that's fine. But that term is not a formal term. I would go more for a triglyceride form that you can get, again, online. You can get them up to 70 or 80% concentrated EPA and DHA, which is the same concentration as EPA and DHA you get in a pharmaceutical product. So all things being equal, I'd try to get a dietary supplement that's highly concentrated EPA and DHA, at least up over 50%, ideally, meaning 500 milligrams of EPA and DHA per 1,000 milligram capsule.
You mentioned the fact you're currently taking a supplement your company makes.
Yeah.
If you couldn't get that, what are some other brands you trust?
Oh, heavens, many. Nordic Naturals, Carlson's, GC Reber is a manufacturer in Norway that makes great stuff. Pharma Marine, also in Norway, makes great omega-3 products. I'm having trouble thinking. I mean, I don't want to just pick on those two being the best. There are many that are high quality like that. There's a trade association called GOED, which is the Global Organization for EPA and DHA omega-3, and they have very high standards. Any member organization, and all the fish oil companies are most of them are members of GOED, and they all adhere to a same set of standards, internally agreed upon standards for fish oil. And anybody who's selling a GOED approved sample or fish oil supplement is good.
So you mentioned krill oil. You mentioned it's the phospholipid type of fat or oil. How would somebody know whether or not it's better for them to take fish oil versus krill?
Measure the omega-3 index.
But is one better? Is there certain populations you'd recommend one versus the other?
Not really, no. I think I would go with either one will give you omega-3s. Typically, you pay more per gram of omega-3. You just normalize it to that. Per gram of omega-3, you're probably going to pay more for a krill oil product than a fish oil product. Partly because it's just more expensive to make the krill oil products. It's just the way it is. That's the chemistry. But gram for gram, I think they're both very good in raising the omega-3 index. So you just have to decide which one you want to pay for and which ones you want to use to normalize or optimize your omega-3 index.
How do you feel about cod liver oil?
It's got a long pedigree, that's for darn sure. It's been around a long, long time. It was historically it was given. I mean, it is obviously oil from a cod, and it's about 20% EPA and DHA, roughly, which is on the low end of omega-3 levels. But you don't take it in pills typically. You take a teaspoon of it, so you can get you get a gram of omega-3 and a teaspoon of cod liver oil. That's pretty good. Typically, it was given because of the vitamins A and D. That's why children in 2 or 3 generations back were getting cod liver oil. But I think it's okay. Again, taken as a liquid, you're going to be able to get a good dose of EPA and DHA out of it.
So it sounds like it just comes back to that number for the EPA, DHA, whether you're getting it through krill, cod, or fish oil.
Basically, that's right. It's not complicated.
Any thoughts on fermented cod liver oil?
Oh, no. Actually, I couldn't even tell you what the difference between fermented and non-fermented cod liver oil is from a fatty acid point of view. I don't know if I've not seen any study comparing the absorption or effects on the omega-3 index of those two forms.
How about algal oil?
Algal oil?
Somebody using that in a form that provides EPA and DHA.
Yeah.
Any difference there? People that have done that and what you see in the testing?
No. Again, it's the chemical is the same. EPA and DHA are fixed chemical molecules, and kind of whether you get them from algae, and just to quickly explain why algae, and we're not talking about seaweed. That's not the kind of algae. This is there are very single-celled, microscopic algal organisms in the ocean that, and there are thousands of different species, but a few of the species naturally make out of sunlight and sugar, basically, they will make EPA and DHA in these single-celled algae. And then the small ocean critters eat the algae, and then the little fish eat the little critters, and then the big fish eat the little fish, and up the chain it goes. And that's why seafoods, again, there's a range in seafoods, omega-3 content we may talk about. But that's the base of the ocean derived omega-3 chain. So some companies have said, well, let's forget killing fish. Let's just grow these algae. And this has been going on for 20 years. And so they can get this specific strain of algae and put it in a big vat in Nevada or Arkansas or wherever and feed them sugar and sunlight, and they'll make omega-3. And then the company has to go through the process of isolating the oil from this biomass and then getting the omega-3 out of it. So it's a complex and kind of expensive process. But at the end of the day, you end up with a capsule that's got a EPA and or DHA-rich triglyceride from algae, and it works just fine, gram for gram of omega-3.
You brought up ALA before. This is the omega-3 found in plants like chia seed, flaxseed.
Mm-hmm.
First of all, let's go a bit deeper into what that is specifically. And then what does the body do with that? We'll get into conversion and what actually happens there to EPA and DHA. But is there a place in the body for ALA specifically?
Not really. I mean, it's much more, to talk about its fate when you eat ALA, much more of it will get just burned for energy, like any dietary fat, or stored in adipose tissue as well. But typically it'll get burned for energy, so it won't get stored up in the membranes like EPA and DHA will. So it's well, we'll have to get into conversion later, but it's not well converted to EPA and DHA. So there's nothing wrong with ALA. It's just not a substitute for EPA and DHA in terms of overall health.
But it's not a substrate used in cell membranes.
No.
Like the other omega-3s from animals.
Not like the other ones are. Because a lot of it does get burned, there's just not much left for the conversions or the incorporations in membranes and things like that. There's much less ALA in a red cell membrane than there is EPA and DHA.
Okay, for somebody relying on something like chia seed or flax again, or some other plant other than algae for their omega-3s, getting the ALA, let's talk about how much, if any, in the average person gets converted to DHA and EPA.
I think the average person, people throw around 5%-ish numbers, like 5% of the ALA might get converted to EPA, but very little of it gets converted to DHA on from EPA. So and people have given huge doses of ALA to folks and looked at the effects on the omega-3 index, and the EPA level will go up a little bit, not nearly as much as 1/5 of the amount given as EPA. So the conversion is not good. But interestingly, when you give ALA and you raise cell membrane EPA, you actually decrease the DHA in the membrane for a little bit. So it kind of washes out. So the omega-3 index really isn't affected. So it's just not a good source of the long chain omega-3s.
Okay, let's talk about somebody taking fish oil. They're getting the EPA, DHA.
Mm-hmm.
Walk me through what happens when somebody ingests that. We know some of it's getting into the red blood cell because that's how you're testing. But where else in the body utilizes that? And then we can go from there.
Yeah. Well, start at the mouth. The capsule gets in the stomach, or the fish gets in the stomach. The oils are released. They go on down into the small intestine. They get absorbed into the small intestine as oils, as fats, with triglycerides. They get packaged by the small intestinal cells into things called chylomicrons, which are big. If you think about unpasteurized or unhomogenized milk, the cream comes at the top. Cream is in particles that has a coating around them of fats. And that's called, in human body, it's called a triglyceride. Excuse me, it's called a chylomicron. It's a very big particle that gets in your blood, carries the fats into the blood, gets to the liver, and gets to adipose tissue, and the fats are offloaded into basically almost every tissue is going to be picking up some of those fatty acids. And then particularly the ones that get in the liver are going to get packaged in particles we call VLDL. Now we're talking about other lipoproteins. And the VLDL particles are the triglyceride-rich particles, and they will carry the first load of omega-3s around the body. And again, they will be delivering omega-3 to every tissue a capillary reaches as the tissue needs it. And eventually it just gets spread out across all the tissues. The way it gets in the red blood cells is it goes into the bone marrow where the cells are being made. And the omega-3s are incorporated into the growing cell membrane there. So that's they get spread out that way. I think the one tissue that we don't really know as much about is the brain. And it seems to get its omega-3s in probably a different form than just being delivered as a triglyceride out of a lipoprotein particle. They seem to get into the brain either as a free fatty acid, unhooked to anything in the plasma, or in this form called a lysophosphatidyl-choline DHA or EPA, which is a kind of phospholipid form. And that seems to be the way they get into the brain.
Okay, so the use throughout the body is extensive.
Yeah.
Let's talk about some of the things that break down when we're not getting enough.
Things that break down, things that go wrong.
Talked about cardiovascular disease. Why don't we start there and go into the details?
Yeah. The omega-3 story really started in the 70s with cardiovascular disease. That's where it showed up first. They really got on the medical world's radar. Where studies in Inuits in Greenland that were being done by Danish investigators found that, contrary to the belief in the 1970s that a high saturated fat, high cholesterol diet would be very bad for your heart, which is still in context, is probably still true. But what was novel about these studies in these native people in Greenland was they were eating virtually no fruits and vegetables, very low carbohydrate, lots of seal, whale, and fish, which is all fat and cholesterol. But they had apparently very little heart attacks, very few heart attacks. Now that's been challenged in recent years, that maybe that wasn't true, but at the time, that seemed to be true, and it started an entire research program on omega-3 and heart disease, which has panned out very nicely over time. So the omega-3s were really shown to do a variety of things. One is they lower levels of one of the blood fats called triglycerides, again, that are carried in the blood, and lowering levels of that is good for heart health. They also, as we alluded to, you mentioned it earlier, the bleeding makes your blood a little thinner, and they do that by affecting the way the blood platelets react to each other. Those are the little semi-cells that float around in our blood, and if you get a cut, they rush over to the cut and plug it up. And the omega-3s, as they incorporate in the membrane of the platelet, they make the platelet a little less reactive, a little less tendency to make a clot. And although you really want your blood to clot, for sure, what you don't want is an inappropriate clot at the wrong time in the wrong place, because a clot in one of the arteries of the coronary arteries that feed the heart can cause a heart attack, and a clot in the arteries that feed the brain can cause a stroke. So that's why people want to have thinner blood, so there aren't these inappropriate unwanted clots. And that's one of the reasons the omega-3s are reducing risk for heart disease, is by keeping the blood chronically thin. They're also, they have a really interesting property of, as the omega-3s are incorporated into the heart muscle, they make the heart, or allow the heart to beat a little bit slower. So the pulse, the heart rate, is reduced a little bit, 2-3 beats a minute, which, in a minute doesn't sound like much, but in a lifetime, it's a lot. And so there's and that's really a sign of improved, what we'll call parasympathetic, sympathetic tone, an autonomic tone, which is out of the autonomic nervous system. And there's this balance between, sympathetic, which pushes you to act, it puts you on high alert. The parasympathetic calms down. And so the omega-3 seem to lift up the parasympathetic and shift the sympathetic down so that it's reflected in a slower heartbeat. And that's also good for the whole circulatory system. And finally, the omega-3s are anti-inflammatory. And so they have a very broad effect across all organ systems that we know of that just slightly pushes down the chronic inflammation that is common in our culture today. And that has widespread effects on disease across, not just cardiovascular disease, but just about any disease. So those are some of the reasons why we think the omega-3s are good for heart health, and some of those carry over to other diseases as well.
I believe they can lower blood pressure too, correct?
Yeah.
And if so, is that related to the slower heartbeat?
Not really, because the blood pressure lowering, it typically takes 2 or 3 grams a day of omega-3 to do that, but you get the heart rate lowering less than that. So I think they're unrelated, but both the synergistic on reducing cardiovascular risk in general.
What about other lipoproteins, HDL, LDL? Any impact on those?
Yeah, when you give omega-3s, we typically see a small increase in HDL, the good cholesterol, high-density lipoproteins. We see a decrease in VLDL, very low-density lipoproteins. Those are the ones that carry the triglycerides primarily. And by and large, we don't have much of an effect on LDL cholesterol levels. It's kind of neutral on that. Or it depends on what you're comparing with. If you take saturated fat out of the diet and put omega-3s in, you'll lower your LDL. But that's not because the omega-3s lowered, it's because you took the saturated fat out. And you replace it with anything, and LDL levels will go down with less saturated fat. But they haven't really got a strong effect on lipid levels per se.
Well, I think this is a good time to bring in seed oils, which we know do lower LDL.
Yeah.
And a lot of times doctors have told patients to use them for that purpose.
Long ago, yeah.
So let's talk about linoleic acid, part of the seed oils there, and your thoughts.
Oh, okay. Well, that's a kettle of fish, isn't it? So yes, linoleic acid is a essential fatty acid. It's very much like ALA on the omega-3 side. It's got 18 carbons like ALA does, but it's an omega-6 fatty acid, which simply means it has a slightly, the first double bond in the molecules is on the 6th carbon instead of the 3rd carbon, which is where the omega-6 and omega-3 names come from. Linoleic acid is the most common essential fatty acid in our diet. We eat probably 6-7% of our calories come from linoleic acid in the modern American diet. Soybean oil is far and away the most common source of it. Soybean oil is about 50% linoleic acid. Corn oil is the same. Cottonseed oil is the same, but then sunflower and safflower oils nowadays are low in LA. In any event, LA comes to us that we can't make it. That's why it's an essential fatty acid. And it is the precursor for a variety of molecules. Most important probably is a thing called arachidonic acid, which is a sort of a cousin to EPA. They're both 20 carbon fatty acids. EPA has 5 double bonds, arachidonic acid 4 double bonds, which doesn't sound like much difference, but the kinds of molecules made from EPA versus arachidonic are quite different in bioactivity. And so there's been a belief for many years that the omega-6 fatty acids, linoleic acid, is pro-inflammatory. And it's gotten labeled like that for a long time. And then people have gotten onto this omega-6, omega-3 ratio as being an important metric, which I'm not a particular fan of. But the omega-6 fatty acids we get from seed oils, linoleic acid, have been severely vilified, and I think inappropriately, because it's the science evidence doesn't support it. So you want me to go into some of that?
Well, to me, there's two different areas to dive into here.
Sure.
Linoleic acid, which is coming from the seed oils.
Right.
And then the processing of the seed oils,
Two factors.
which in and of itself is likely problematic.
Yeah, and those are, you're right to say those are two completely separate questions. The linoleic acid could be neutral or even good for you, which I think it is. And there may be other products made in heavily reheated oils that might not be good for you, but it has nothing to do with the omega-6s. So it kind of like to separate those two questions. They're really unrelated. The omega-6 fatty acid part of the story I'm most familiar with, because we've done studies looking at levels of omega-6, levels of linoleic acid in the blood. And certainly the levels of linoleic in your acid in your blood are pretty well driven by how much linoleic you eat, because you can't make it. So it has to come from somewhere. And it comes in our diets. And the people that eat the most have the highest levels of linoleic acids. So we've done studies both in around the world, as well as in UK, as well as in the United States, looking at blood levels of linoleic acid, which is a marker of intake. Higher levels in the blood, higher intakes. We've compared the risk for 3 or 4 serious diseases, including death, as a function of the blood level of linoleic acid. So in some of our studies, we'll take a group of, say, 100,000 people, just regular folks who are part of some of these long-term observational studies. We know what their blood level of linoleic acid is when the study starts. They're usually in their 40s or 50s when the study starts, and maybe their 60s. We then follow them over 10, 15, 20 years and see who develops what kinds of diseases. If linoleic acid was a bad player, was bad for you, higher levels in the blood should predict higher risk for major disease outcomes, meaning the more you got in your blood, the more disease you ought to get. That's the hypothesis that the omega-6 is bad for you, would say. What we see is uniformly that the higher the level of omega-6 linoleic in the blood, the lower the risk of getting heart disease, of getting diabetes, of dying from anything. Put everything together in the pot, premature death. So low omega-6 associated with higher risk for premature death. Low omega-6 linoleic associated with higher risk for heart disease and diabetes. That's not the kind of thing you would find if linoleic acid was bad for you. You would find the opposite. So being driven by the data, I think that speaks more to me than looking at metabolic pathways and saying, oh, well, this thing competes with that thing, and therefore this is going to make that, and that's going to make this, and then you're going to get sick because of that. I don't care about that stuff. If the actual life and death data say the omega-6s are good for you, then you can talk about metabolic charts all day long, and it doesn't make any difference.
And we do know they are essential.
We do know they're essential.
Again, yes. Separating that from the fact that when these oils are processed, a lot of nasty things are done.
Well, I guess it depends on what you mean by processed. I mean, when they're used at McDonald's to fry French fries for 5 days in a row, yeah. But that's not standard processing of oils. Uh, Usually the oils that you get, like at the grocery store that are soybean oil, they have, again, like about 50% linoleic acid in them. And that's what gets into, I mean, we don't just drink oil. I mean, like you alluded to that earlier. Yeah, in the 70s, doctors were telling people to take tablespoons of corn oil to lower their cholesterol, because it did, if they replaced saturated fat for it. Anyway. But I'm not convinced that just the standard of cooking oil, vegetable oil that you get in the grocery store has been processed and damaged in a serious way that affects health. It's hard to imagine how that could actually be the case if a biomarker of seed oil intake is the blood linoleic acid level, and to some extent it should be. The more linoleic acid's in the food, the more it gets in your blood, the higher level you got, which kind of means the more oil you're eating. And if these oils are dangerous or harmful, then you would think, well, there should be some health consequence to that.
But wouldn't we need to parse out the difference between getting them from the oils versus whole foods?
Well, it'd be nice. I don't know how many people. That's the problem. I think in studies we've done, we just do large populations, and I don't know off the top of my head, in the general population, which is what we're working with, what percent of the linoleic acid comes from what we would call a whole food versus a food that's been prepared, processed, for any number of ways. It's a great question. If in fact 90% of the linoleic acid we get is from processed foods, then we would have to say those processed foods, if linoleic acid in the blood is a biomarker of the intake of those foods, that they're not harming us. I mean, maybe we could be even healthier potentially without them, but they seem to be living longer with higher levels. On the other hand, to your point, if we found that 90% of the linoleic acid's coming from natural, unprocessed, and it's hard to imagine this in America, foods, then you'd say, yeah, well, maybe it's just the kinds of foods you're getting them from. That's why it's. But I think that's a good research question that I don't know the answer to. And since you raised the point, I'm going to try and figure that out. It's a good idea.
All right, sounds good. Let's talk about the ratio. You quickly mentioned when you're sharing that you're not a fan, omega-6 to omega-3. Why not?
Oh, well, one reason I've already mentioned well, I didn't say it out loud. When you make a ratio of things, typically it's a bad to a good. You don't make a ratio of a good to a good. There's no point in that. It doesn't tell you anything. And if linoleic acid, the primary omega-6 in the diet, is good, and we think omega-3s are good, then why make a ratio? That doesn't make sense. Secondly, when we say omega-6, we're talking about in the diet 2 different fatty acids, in our blood about 7 different fatty acids that are of the omega-6 family. 2 of them in our blood come from our diet, or, well, one of them does, linoleic acid. Arachidonic comes a very little bit from our diet and mostly from metabolism. And the other 6 fatty acids that are omega-6 in our blood come from the metabolic linoleic acid being made into them. So we really can't control that very well. That's internal metabolism, and we really don't control it. So when you say omega-6, omega-3, well, which omega-6 are you talking about? I mean, it's not precise, which is what I don't like about it. If you did a linoleic acid to alpha linoleic acid ratio, well, maybe that might be useful. I mean, at least you're specific about what you're talking about. The other factor is you can have a high level of omega-6 and a high level of omega-3 in your blood or your diet, and you could have a low level of omega-6 and omega-3, and you can have exactly the same ratio. It's a ratio, right? So you can't tell, you don't know what to do about it. And that's part of the problem with the omega-6 omega-3 ratio is if you have a ratio that's too high by current standards, the typical approach is, well, lower your omega-6. I mean, you can do a variety of things. You can raise your omega-3. That's the right thing to do. If the omega-3 is EPA and DHA, part of the problem with definitions. Omega-3 is not just EPA and DHA. ALA is there too, and they're not the same. So I don't like the non-specificity of omega-3 or omega-6 because they don't really tell you which fatty acids you're talking about. They don't communicate well. And again, if you want to improve your bad ratio, if you decide you're going to increase your EPA and DHA intake, that's a good response, because that will always lower the ratio. You take more EPA and DHA, the ratio is going to drop. But if you say, well, hey, I'm going to just cut back on my omega-6s to fix my ratio, well, that's going to take you down a bad rabbit hole. Because based on our evidence, the lower the levels of omega-6 in your blood, linoleic, the higher your risk for heart disease, diabetes, and death. So why would you want to reduce your omega-6 levels? That doesn't, I mean, even if, we kind of have this idea that that the omega-3s are really good, and anything that perturbs the omega-3 level is a bad thing. Well, that's not necessarily true, because it could be that linoleic acid, higher linoleic acid, which would reduce the conversion of ALA to EPA, true, then that must be bad. Well, what if linoleic acid has its own independent beneficial effects that have nothing to do with the omega-3s? Well, then reducing its intake is not a smart thing. That's the trouble with thinking this black and white, good guy, bad guy mentality on omega-6, omega-3 ratios, which is why our blood test is focused, the omega-3 index is focused on EPA and DHA. We don't care about omega-6. We don't care about linoleic acid. What Americans need is more EPA and DHA, and not to worry their socks off about omega-6, which is unfortunately what's going on now.
All right, to close the chapter on seed oils, before we move forward, go ahead if you want to share something.
No. I just feel like I was running off at the mouth there. But
no, that was great.
Okay.
So you're not afraid of the seed oils.
No.
Linoleic acid, you're a fan of. It sounds like the one piece you still want more clarity on, which I'd like more clarity on, is getting the linoleic acid through whole foods versus the heavily processed seed oils.
Yes, I'd like to get more clarity on that. The next guy that asked me that question, I want to have an answer for it and say that, the evidence we have that 80% of the linoleic acid we get comes from foods that are unprocessed. Well, that'd be great. That'd be good to know. But I don't think that's going to be the case. But
yeah, I need to do more research too. The one piece I hear people talk about is when it comes to grain-fed animals like chickens and pigs, the linoleic acid in their animal products are higher than if they're eating their natural diet.
Could be.
So I know people are getting linoleic acid through those means who are eating those foods. If somebody's eating animals that are eating the proper diet, I'm not sure how much linoleic acid they're getting. Again, to caveat the whole thing, linoleic acid is essential.
Yeah, there's
a lot of different layers here that we need to make sure we're clear on in a nuanced discussion like this.
Yeah, and to your point, there's no controversy. Even the most ardent anti-omega-6er is going to say, linoleic acid is an essential fatty acid, just like vitamin C and vitamin A, or et cetera. It's essential. You can't make it. The argument is about how much we should be eating.
And if it's been chemically altered.
Well, if it's been chemically altered, it's not linoleic acid anymore. I mean,
well, I'm just saying through processing.
Oh, you mean if
whether that oil is still unadulterated?
Yeah, we kind of worship at the altar of unprocessed and organic, and I'm not sure all that's evidence based.
Let's talk about trans fats.
It's philosophically nice. Trans fats.
So the way I understand trans fats, bad. Everybody is in agreement there. They've primarily been removed from the American diet.
Largely.
But they can still sneak in if they're under a certain percentage. So
Right.
talk
If per
about that
serving.
loophole there and why they're bad.
Yeah, well, trans fats have, what they are. They're generally produced. I mean, there's two general types. There's some natural trans fats. That's a pretty small percent of what we eat. And then there's what we'll call the industrially produced trans fats. And these are made from vegetable oils that are hydrogenated, actually partially hydrogenated, meaning that they're made solid, chemically made more solid, like Crisco is the kind of classic. Hydrogenated, and I'm sure it's probably not anymore, but that's the way it used to be. So what happens is you chemically transform some of these polyunsaturated fats into monounsaturated fats with the shape of the double bond flipped. Instead of being like this, it's like this, which doesn't say much to the non-chemists out there. But anyway, it's they behave once they're hydrogenated. A monounsaturated fat, which like oleic acid and olive oil, would normally be liquid at room temperature, but you can have the same 18 carbon, one double bond molecule that's a trans fat, and it's solid at room temperature. So the food industry wanted to make stable fats that were shelf stable. Anyway, they behave exactly why they kind of cause inflammation, why they raise LDL cholesterol, why they lower HDL cholesterol. I don't know the actual mechanisms of that, but I do know that there's a lot of evidence that there's increased risk for cardiovascular disease, particularly in diets that are higher in trans fats. And you're right, the FDA has essentially not banned them, but say you had to put them on the label. And so that effectively bans them, because then products have to have, if they have less than, I think is it 1 gram per serving?
I forget the exact number. I know they have
chips,
a low number there that they can sneak
there's
under.
A number. And if you're below that number, you're right, you could just say 0, which is a little disingenuous if you're getting picky about it. Because you can eat, say 1 serving of potato chips. Well, eat seven servings of potato chips, and you got a huge load of trans fats in, even if it's less than 1 gram per serving. So that's the problem. Just back to blood tests. I mean, we do a blood test. We measure the trans fat levels in the blood spot, because we can do this on a whole blood pattern. And so we've seen over the years. I mean, it's been interesting just to look at the aggregate samples coming into OmegaQuant over the last 7, 8, 10 years, and you can see trans fat levels is dropping. It's not because people are trying to avoid them. It's because the food industry is getting rid of them. And so they're just not there as much anymore. They're not completely gone. And you can certainly work your way around it by using non-packaged foods that are, mom and pop kind of cooked. But anyway, trans fats are a good thing to avoid. And they've seemed to have kind of lost the concern, because I think they've been dealt with pretty well.
Let's bring C15 into the mix.
Hey,
this
is
really taking the health world by storm. There's a company, Fatty15, and they have a supplement, which is apparently essential. Saturated fat.
They say it is.
Well, this is why we need to talk about it. And it's often compared with omega-3. So I think it's important we bring it in and talk about your thoughts.
Great, yeah. So C15, 15 means the number of carbons in the chain. And we talk about omega-3, there's C20 or C22. Most natural fats, quote, in the diet are odd numbers, odd chains, 14, 16, 18, 20. So you got C15, so it's an odd number. That we can trace its origin. Typically, most of that in our diets comes from dairy products, because dairy fat is made, of course, in the udder of a cow. And there are enzymes and particularly processes in the udder of the cow that will make what we'll call odd chain fatty acids. And that gets incorporated in milk and then cheese and butter and all that. So C15 0, 15O, meaning no double bonds, meaning a saturated fat. Like palmitic acid is a 16O saturated fat. These are the ones that typically raise cholesterol. Well, there's small amounts of 15O in our diet now, if we eat dairy, particularly. A veterinarian, Dr. Ben Watson, has made some discoveries, first of all, in dolphins. Has come to the conclusion that a low level of C15 in the diet has lots of bad health consequences. And I've talked about this before. And has been now defined as an essential fatty acid, and is now being called a longevity nutrient. And I personally think that the marketing is far outpaced the science here. There is very little human data on C15. Certainly supplementing with C15, which has been done. And the one study that I'm aware of that's given C15 in the doses recommended by the manufacturer had the unfortunate outcome of half the people that got the C15 didn't even see an increase in blood C15 levels, which is kind of surprising that with omega-3, you always see an increase. So half of them didn't even see an increase, and the half that did really didn't get any significant metabolic health effects from it. And that's pretty much the extent of the supplementation data. There's some observational studies. We've done studies with it in the past, looking at C15 as a marker of dairy intake. And we've seen that higher levels of C15 in the blood and C17, which is a similar fatty acid, were linked with lower risk for diabetes. But that doesn't mean the C15 is doing that. It just means that the C15 is a marker of dairy intake, and something about dairy is doing that. So we can't draw cause and effect lines between what we observe in blood studies and disease outcomes, because those are only associations. They can't be considered causations. So I think the evidence is really thin. I mean, the promoters of C15 have also done studies where they put C15 on different cells in culture, different cell types, and put omega-3 in. They get these different readouts of different molecules that are made, and they extrapolate that to the whole of the human body, to all of human health. And I think that's just an inappropriate extrapolation. You can't, until you do the studies in humans to show that there is a actual need for C15 that cannot be met, and that actually serves. You don't call something an essential nutrient if you can leave it out of the diet and you don't die. I mean, that's what essential means. It may be conditionally helpful nutrient. It may be bioactive nutrient. That's possible. But to call it, I can't even call the EPA and DHA essential nutrients, because you don't have to eat them to live. I mean, you look at vegan or vegetarian societies that don't eat any EPA and DHA, and they live. Indians, East Indians. So EPA and DHA are not essential. To call C15 essential with so little data, published data, to me, it's a lot more marketing than it is science. So I'm not convinced yet, put it that way.
All right, a lot we can dig into here. Let's really take our time.
Sure.
Starting with, you mentioned we get it from dairy.
Yeah.
Are there any other sources? And why I want to go here is somebody on a vegan diet, are we certain they're not getting any?
I think a little bit can be made from the bacteria in our large intestine, and then absorbed. It's just always been, there's some in fish. You can get some in fish too, but that vegan's not going to be eating fish either. I would expect, in fact, that's an interesting point. I'm not sure I can do it, but you're making me think about going back to the studies we've done in vegans with dried blood spots. looking at their fatty acid levels and seeing if C15 was lower in them than it is in non-vegans. The trouble is, we have to do a special analysis in the laboratory to actually be able to pick out C15. There's so little of it in the blood. It's a very, very tiny peak. But maybe there's a way we can, I mean, you're getting me to think, Jesse, here.
Well, the reason this is important.
Getting me to think of new studies I want to do.
Well, that's great.
I know.
The reason this is so important is because it is termed essential. If bacteria can make it in the body or we can get it from a plant source, well, actually the latter wouldn't be, could still be essential.
Well,
but if we're making it in the body, basically I just want to look at the claims here and see if there is any validity of it being essential. You're making it sound like no, but I'm just trying to dig in at some of the nuance here and see if they have any ground to stand on.
Yeah, and again, what's the classic thing you would do to prove a vitamin C is essential? Let's just back up to something real simple. You would take a rat. You can't really do this in humans. You shouldn't do this in humans. You make a diet for the rat. You give it every vitamin known to man, plus fat and carbohydrate, etc., and you keep all the vitamin C out. Well, rat's not a good one because vitamin C, they make vitamin C. Let's do guinea pigs. Guinea pigs don't make vitamin C, just like us. We can't make it. They can't make it. Give them a otherwise complete diet, and make sure there's no C15 in it, and see how many generations they keep going. If they keep living and reproducing, then the C15 is not essential. If you add C15 to the diet and it doesn't really improve their reproduction or lifespan or anything, then it's certainly not essential. That's the way you show an essentiality of a nutrient. You give a diet with it and without it, and if you have the diet without it and the thing dies, it was essential. I mean, it's pretty simple. Being essential and being bioactive are different things, right? Again, EPA and DHA are great examples. They're bioactive, they're healthy, they're good for you, but they're not essential in the diet. So yeah, whether you can make it in your gut, I don't know how much you can make in your gut and from what substrates you would make it and what role it's playing. And if you didn't make it in your gut and you had 0 levels in your blood, would you be a sick person? I don't think so. But those studies haven't been done. That's what you'd need to do to document a claim of essentiality.
One of the interesting findings you brought up is this one study where half the people taking the supplement, they weren't finding any C15 when they were doing an analysis.
Well, it didn't go up.
Did they discuss in the paper what they thought was happening there, or do you have any thoughts?
I don't know what's happening there, because there's always a little bit in the blood. Again, we'll see it. It's a very, very small peak in a chromatogram, which is what we use to measure fatty acids. And I'm sure the people, I have to look at the paper again, I'm sure there's some level at baseline at the beginning of the study of C15 there. And the point in the study was when they gave the 200 milligrams, it didn't increase. So it's not like it wasn't there at all. Why didn't it increase? I don't know. I don't really have any good explanation for it. But it's disappointing that you would think that the recommended dose would at least raise blood levels. And if it doesn't do it in half the people tested, that's, well, I'm not sure I'd buy it.
One of the problems I see with the marketing is this comparison, and it's not necessarily direct, but they're alluding to this comparison between omega-3 and Fatty15. And on the website, you can see this comparison between the two of them. And underneath it, it even says Fatty15 has this distinct advantage. So again, it's close. It's not necessarily saying this is better, take this instead, but people may interpret it that way.
That's exactly the way it's intended to be interpreted.
So I see that being troublesome, where somebody thinking that this is better, and say they only have a certain amount of money, they only want to take a certain amount of supplements, and they decide to offer Fatty15 versus a heavily researched supplement like omega-3s.
I think that's a problem too. I mean, that's not why I'm kind of down on C15. I'm down because I just don't see the evidence for it. I think the way they came up with this comparison with omega-3 and C15 is not from human studies or even animal studies. It's from cells in culture. When you sprinkle these fatty acids on the cells and they respond in a certain way. I'm not even sure they're sprinkling on cells in a physiologically relevant way. I mean, I don't trust those data as meaning anything. It can't be really extrapolated out to human health. And the average reader doesn't know that. The average consumer doesn't realize that you can't just take the result from some cell culture experiment and say, therefore, A, B, and C is good for you. It's just far more complicated than that.
And a challenge with all this is people having the ability or the time to go into the science and see what's really happening. Stephanie's actually been on the show before.
Mm-hmm.
I've taken this supplement before.
Mm-hmm.
And even somebody who is in this world interviewing the experts, it was very compelling.
I know. Yeah,
and I'm still confused. I'm not saying I'm still in the mix of learning here and trying to piece it all together. But I feel for people where they're not going to go to the paper. And if they do, they're not going to read the details. Who has the time or the expertise? You do. I don't. Most people don't. So going on a website or listening to a podcast interview is how a lot of us are going to get our information.
Yeah, well, it's a free country. I guess people can say what they want, and ultimately the truth will come out, I suppose. If indeed C15 proves to not really be what it's cracked up to be, eventually people will stop using it, I would think. I mean, I'm kind of interested in doing some studies myself, using the data that we have just to look and see. I mean, we've got data in two large cohorts, Framingham study and the Women's Health Initiative. And we have C15 levels in the red cells measured in, 8,000 people. We know who died before who else died. And so we could pretty easily test the hypothesis that having a higher C15 is associated with longer life. I mean, and if it is, it is. If it's not, it's not. But even if it's not, it's pretty convincing that it's not the longevity nutrient. Number one, if it is associated, it can be this. It doesn't necessarily mean it's C15 that's doing the job. It could be, again, a marker of other nutrients in the diet, like dairy, that may have health benefits. And it's not the C15 that was there. It's just that it's a biomarker of the intake of dairy. So you can't, you have to think through how you interpret the findings of these things. But if I would go into a study like that saying, well, the hypothesis is that this is people with higher levels of C15 are going to live longer, because that's what longevity is, right? And if it turned out we couldn't find any relationship between the people that the highest and the lowest levels of C15 had the same lifespan, I would say, well, that hypothesis has not been supported. So one can do with that what they want.
Let's step away from Fatty15 now. Come back to omega-3.
Okay.
We've gone deep into supplements, but let's talk about food.
Mm-hmm.
Somebody that wants to at least get part of their intake through diet, what are the best sources?
Fish and I think we like to talk about a called SMASH, acronym SMASH, which stands for either salmon or sardine, depending on which one you want to start with. But S, I'll say salmon. Then A is usually, rather M is mackerel. A would be, I like to say albacore tuna, white tuna. And others would say anchovies, but I'm not sure who eats that many anchovies. S again would be sardines, and then herring. Those are classic oily fish that have the highest amounts of omega-3 per serving. Things like orange roughy. What am I blanking on? The one that's really cheap that tastes like chicken.
Tilapia?
Tilapia, thank you. Almost no omega-3 in the shrimp. Virtually no omega-3 because they're very low in fat. If you don't have fat, you don't have omega-3. So there's a whole range of, you can't just say eat fish, then you go get Mrs. Paul's fried, fish sticks, there's no omega-3 in that. It's the oily fish that have the most omega-3. So that's what I would point people to first. Oysters are actually pretty good in omega-3 too, for some odd reason. After that, you're pretty much looking at supplements or fortified foods. There's certainly, you can get higher omega-3 eggs, because some form of feed chickens with either ALA, which doesn't do a lot, but sometimes they feed fish oil itself directly to chickens, and that will raise it in eggs. Some bread. I guess you got to be careful in omega-3 fortified foods, because a lot of times it may just be ALA, and that's not what you want. So then food-wise, it's quite a narrow choice, and then you get up into supplements. That's the other way to get them.
One of the things you come up against when you start talking seafood is toxicity. When it comes to fish, again, seafood as a whole, how do you think about that as somebody begins to incorporate more of it?
Yeah.
Is it a concern for you?
No. Particularly the fish I just mentioned, the smash fish, are all fish that have virtually no mercury in them. The fish that we are concerned about with mercury, and I think still this is even overblown, swordfish, king mackerel, which is a specific species of mackerel, a really big one, a long-lived one. Thing called tilefish and swordfish and shark. I think those are the major ones. Well, not many people eat those fish. I mean, those are the ones that are highest in mercury. The fish that I'm talking about that are high in omega-3 are low in mercury. But even that begs the question: is the mercury concern really a real thing? I mean, the concern is a real thing. Is it warranted? Is the question. And we've been we did a study. Joe Hibbland was the lead author on it a couple of years ago, looking at all the studies around the world, looking at fish intake in pregnant moms, and the mental health outcomes of the kids. And what we found was that the higher the fish intake, fish writ large, because a lot of these studies didn't really quantify the kind of fish, but higher the fish intake, the higher the IQ of the kid. Like comparing women who are eating over 12 ounces a week versus none, there's like a 7-point IQ point different in the kids. And that's regardless of the mercury content. The mercury scare got started in the Faroe Islands based on the consumption of pilot whale, not fish. These pilot whales in that island, were richer in mercury, and there was high levels of mercury in those kids. But then you go to another place like the Seychelles Islands, where there's a high fish intake and fairly high mercury intake too, but not as high as in pilot whales. And the kids there, the more fish they ate, the better, the healthier they were. The mercury scare, the FDA did a huge disservice to pregnant women 25 years ago when they put out those warnings that pregnant women should avoid essentially fish because of mercury, not realizing that what they had just done was push pregnant women away from the most important source of DHA for their babies in order to accommodate a reasonably groundless fear of mercury. So the documented drop in fish intake in pregnant women after the FDA's warnings were put out, it's very clear. And the evidence now says the DHA you get, the healthy things you get from eating fish far outweigh any potential adverse effects of mercury. But people are really a lot more scared about putting bad things in their mouth than attracted to putting good things in their mouth. If something's a possible toxin, they'll avoid it, even if the evidence for it is minuscule and the actual harm is undetectable. Just the fact that a federal agency says it's a toxin, you'll stay away from it. But I'm afraid it's scared people away from a really good source of food with the net effect of being adverse affecting our kids.
For a pregnant woman who does have that fear of mercury, do most of the reputable fish oil companies test for it if she wants to get her omegas that way?
Yeah, but you don't. Just the very fact that mercury is a water-soluble component of fish and sticks to the proteins doesn't stick. It's not oil soluble. It doesn't go into the oil. When the oil and water partition, when you're grinding up the fish to get the fish oil, the mercury doesn't go in the oil phase. It stays down in the aqueous phase. So there is no mercury in fish oil supplements. And it's not because they're going out of their way to keep it out. That's just the way mercury behaves. It's not non-polar, so it doesn't go in the lipid part. So the fish, that's not a worry. Pregnant women certainly take and should take EPA DHA supplement, DHA particularly, during pregnancy. And especially, as you say, if they don't want to eat fish. But what's really interesting is that the fish are a great source of selenium. And selenium can block any bad effects of mercury. And if you have a ratio of selenium to mercury that's very favorable to selenium, it's going to be very good for you, not bad for you. But if you just focus on the mercury part and forget the selenium part, then you're getting only half a picture of the health effect of a food, of a fish.
It's a complex story.
Isn't everything?
So pregnant women, actually, let's take it back a step further.
Mm-hmm.
A woman who is trying to get pregnant, even before that, they want to prep their body to get pregnant. The dosages we've been talking about today of omega-3s, would they want to up that through that stage before getting pregnant, pregnancy, while they have a baby on board, and then during breastfeeding?
Yeah. The levels we were talking about earlier would be great for pregnant women if they would do it. I mean, they don't need to be higher than like the 500 to 1,000 milligrams we talked about, VPAD. That'd be fantastic. Most people will recommend at least an additional 200 milligrams of DHA during pregnancy. As far as pre-pregnancy, not much literature there on the pros and cons of the benefits or none of preloading. It makes intuitive sense that you'd want to preload your body with omega-3 because the baby's going to take a lot of it when in the third trimester, particularly when the brain is being built. It would just make sense if you're trying to get pregnant to be as well nurtured as possible from any perspective, particularly omega-3. Whether the father's omega-3 status is important is there's some interesting studies looking at sperm quality as a function of omega-3 intake, and it seems to be more motile, maybe survives a little better. I was recently at a conference on horse nutrition, And one of the benefits of omega-3 and racehorses, horses in general, is improved fertility, what they tell me. I mean, I haven't seen the data, but and when they create an embryo in vitro, do some in vitro fertilization and make an embryo, that would be then implanted in another mare. If there's a high omega-3 content, that embryo stays alive, is more viable. So maybe that would be great if that was true in humans. And I haven't seen too many studies look at that, but that would be a reason in the whole area of birth and reproduction. Certainly during third trimester is the most important part of time to have the highest omega-3 level coming in mom. And then to keep it going during breastfeeding. Because if you stop taking omega-3, the levels in your breast milk just drop like a rock. Within 2 or 3 days, they go down. So back to OmegaQuant, we do have we have a blood test, but we also have a milk test. That's the same thing. You put a drop of milk on a card, mail it in, and we can measure the amount of DHA in your milk. And if moms want to keep their DHA levels up, we can tell them how much to take. But it's important to take it throughout lactation. I mean, the kid's brain is growing till mid-20s? Obviously most of it really early on, but that's the time to really be sure the omega-3s are there.
You mentioned horses there. How much omega-3 would a typical horse get in its regular diet? And then extrapolate out mammals as a whole. Obviously, this is something that's important for us as humans, but what about other mammals? And how much are they getting?
Yeah. In their diet normally, they're getting ALA, but they're getting 0 EPA and DHA, and they have very low omega-3 index in a horse. This is obviously horses don't eat fish. They're vegetarians, right? And so the question of giving EPA and DHA to a horse is more medicinal in a way. Again, you're giving bioactive compounds. You're not giving nutrients because these are not essential nutrients for horses. But they can have health effects in horses, anti-inflammatory against some of these reproductive forms. But interesting, the horses are. What blew me away at this conference, another guy talked about omega-3 in horses. You only have to give, 3 or 4 grams, 5 grams a day to a horse to get a meaningful bump in omega-3 levels. Well, on a per kilogram basis, that's hardly anything compared to a human. I mean, these things are 1,200 pounds, and be giving kind of human equivalent doses is surprised me that you didn't have to give 30, 40, 50 grams of EPA and DHA to see any bump, which you would on a per kilogram basis for a human. So horses respond interestingly. Like I mentioned earlier, we did dolphins at SeaWorld, measure the omega-3 level, and we have measured several, penguins and flamingos, and we did a whole bunch of different species at SeaWorld because their veterinarian was just interested in this question. And if it's a seafood eating animal, it's going to have a high omega-3. If it's a cow, if it's a black rhinoceros, if it's these are not SeaWorld animals, giraffes, really low omega-3 because they don't eat fish. I mean, it's pretty much the same thing. But there's a whisper of DHA and EPA in their blood being made from the ALA, but is very low. But apparently enough to live and reproduce.
With your research and your message getting out there, along with a lot of other people in the health world, and people, you would assume, wanting to consume more fish, take more of these omega-3 products, how do you look at sustainability?
Yeah. That's kind of what I'm most excited about in the future is not only more of these algal oil type products, but there are people, particularly in Australia and England, that are doing good research using genetically modified plants, land plants, soybeans, Camilla, Camellia.
Chamomile.
I'm not sure I know the name of it. Yeah, that's it. Thank you. Camelina. Is that right? That's it.
Oh, that's not one I'm familiar with.
Well, it's something in Australia. I think it's a weed. But in any event, you can transfer some enzymes from certain kinds of plants to other plants that will allow the plant to produce in its oil EPA or DHA. But it's a genetically modified product. No, it's a GMO. So we, have to kind of get over the phobia, the GMO phobia, in order to embrace a omega-3 product produced from a land plant. But that would, if we could actually do that and have these two important fatty acids created on land with plants instead of having to take them from the sea, that would be fantastic. Then sustainability is not an issue. And then it would be essentially infinite supply, and we wouldn't have to kill any fish to get it. But for now, the vast majority of fish oils come from the fishery off the coast of Peru, which is basically anchovies and sardines. And they're very careful about, they frequently shut down their fishery because they hit a certain threshold and they stop. They're very interested in making it a sustainable fishery, and that really is where almost all the fish oil. There's some that comes from Alaska, some from Norway, but the big bulk of fish oil comes from off the coast of Peru.
So we've made the connection, omega-3s to cardiovascular. You mentioned inflammation in there. We talked about during pregnancy. What about cognitive decline? Let's bring them in that realm.
Yeah, that's good. It's similar story, again, when the brain is, DHA is the most abundant polyunsaturated fatty acid in the brain, next to arachidonic acid, with the next one down. So it's a major component of neurons and synapses and different structures in the brain. So DHA is important, no question. And so people have always thought, well, maybe we ought to, and just to follow the logic, we look at autopsy specimens on people who died of Alzheimer's disease, and the DHA content is lower than in people who died of the same age of dementia-based diseases. And we know that red blood cell levels of DHA being low predict a increased risk for dementia from a couple of Framingham studies. And now we have just working on a manuscript today, study that took data from 19 different cohorts, pooled fatty acid levels and looked at risk for dementia and Alzheimer's disease. And it's the same story. The higher the levels of EPA and DHA, not just DHA, actually EPA too, which may be an anti-inflammatory component, because EPA per se is not found in the actual flesh of the brain. But it does circulate through the brain, through the capillaries, so it's may be playing a role. In any event, higher levels of EPA and DHA linked with about 10 to 12% lower risk of developing dementia or Alzheimer's disease over time. So the story is coherent. It makes sense. I'll just jump back. Having said that, we just published another study looking at blood linoleic acid levels, omega-6, and dementia. This was done in the UK Biobank, which is a cohort of some 400,000 people in the UK that were screened, 15 years ago. They were between 40 and 70 years of age, general population screen, basically. And they've been followed now. We have blood or plasma linoleic acid levels on these people, and we looked at the question, is there a relationship between linoleic acid levels and risk for dementia? And same story, higher levels of linoleic acid, lower risk for dementia. people who had the highest risk for dementia had the lowest levels of linoleic acid. So it's the same as kind of the heart disease studies, same story as total mortality, high linoleic, good. High omega-3, good. I mean, I kind of see omega-6 to omega-3 as, or linoleic acid, EPA, and DHA, to be specific, as partners in good health. They're both good. And there's no reason to think that one of them has to be good and the other one has to be bad.
Any connection between that trifecta and mood disorders?
Yeah, I mean, some. I mean, again, the work we've done in this area on anxiety and depression, we have seen the relationship others have seen, that low levels of the omega-3s in the blood are associated with higher risk for depression and anxiety. And randomized trials, I mean, this is one of the interesting things. This is depression. I guess we'll call that a mood disorder. People we've done lots of trials giving omega-3 supplements to depressed people to see if you can fix their symptoms over the years. And when we look back at those studies and ask the question, was there a relationship between the EPA to DHA ratio in the supplement and the effectiveness of the product? It turns out that it's the products that are richer in EPA, like it's 60-40 EPA to DHA or 70-30, something like that, as opposed to the opposite situation where DHA is rich. It's the EPA-rich products that seem to work, but not the DHA-rich ones, which was, again, counterintuitive to the idea that DHA is in the brain, so you ought to give DHA. Well, it's just not always that simple. There may be something. I mean, that may be the one case where we have some pretty good evidence that an EPA-rich product is better for depression than a DHA-rich one, but we don't really have that data for heart disease.
When it comes to the anti-inflammatory benefits of omega-3s, I could see that being a huge benefit when it comes to chronic inflammation, but acute inflammation is the body's natural response to healing. So what I'm getting at with this, have you seen anything where somebody taking too many omega-3s or upping their omega-3s, and then they're blunting that natural response?
That's a great question. I have not been asked that before. And I'm thinking, no, short answer, no, I haven't seen that. But I'm trying to think of how you'd study that. I guess you could look at the rate of wound healing in a way after a uniform wound in an animal. You could, I suppose it can be done in humans too, but if you want to get at the acute inflammatory response, the omega-3s probably do blunt that, but do they blunt it to the point where it's pathological? Haven't seen any evidence to that effect. Again, if you look at just to back up from the inflammation thing, but when you think about omega-3s in general, you think of the Japanese who have this chronic lifetime. I mean, from -9 months of age through their whole life, they have a lot of omega-3, a lot more than most of us. And if there were really adverse effects of it at that level, you would think it would show up. But the Japanese live about 4.5 years longer on average than Americans do. I like to attribute that to omega-3. I don't think I can do that, honestly, because there's a lot of other factors. But if you think about the Japanese culture in general, they smoke more than we do. They have more high blood pressure than we do. They have more stress than we do. That's in the popular mindset. And yet, they live 4 years longer. So how do they do that? And if there was if high omega-3s were in some way detrimental to an inflammatory or immune response, you would think it would manifest somewhere in a culture like that. Anyway, I've not really seen any evidence that a acute response to inflammation from an injury is blunted by having omega-3.
Any other major benefits of omega-3s we haven't talked about?
Well, when you can't feel an omega-3 deficiency. It's kind of like you can't feel a high cholesterol. You can't really feel a high blood glucose to a point. So when we give people omega-3s for high triglycerides, for example, give them for some other reason, it's not uncommon to hear that people will say anecdotally that, oh, my knees don't hurt so much anymore, or my shoulder feels better, or, there's a joint benefit to the taking the omega-3s, and that would probably be part of the anti-inflammatory component of it. So yes, for joint health, I think there's some reasonably good evidence that omega-3s are helpful. For eye health, we're seeing higher levels of omega-3 associated with lower risk for age-related macular degeneration in the eye. And there's some controversial evidence about omega-3 in dry eye disease, whether it's effective or not at reducing dry eye. But the eye is, of course, that's an inflammatory condition. So that's an area where we think we might see some benefit. There's some benefit been shown in glaucoma, sticking around the eye here, and certainly in the diabetic retinopathy that occurs in the retina. People who have diabetes, there's been less damage done to the retina in people with the higher omega-3 levels. Though, again, some of these things have not been subjected to randomized trials. A lot of this is observational associations, but that makes sense from an anti-inflammatory point of view. Other conditions, those are really the big ones. I mean, again, we haven't talked much about diabetes, and the observational epidemiology studies suggest higher omega-3 associated with lower risk for diabetes. But does that mean you can take omega-3 and, correct your blood sugar? Well, probably not. So there's, to the extent that diabetes is also an inflammatory disease, aren't they all, right? It makes sense that high omega-3 would be helpful. And unfortunately, high linoleic acid is also helpful in preventing diabetes. So there's that thing again.
Anything other than the inflammation you can connect from omega-3s to diabetes?
Not directly. I mean, the omega-3s, as I said, they live in cell membranes. And by virtue of being in a cell membrane, they change the physical properties of membranes. And of course, every cell is a membrane, and every membrane is terribly important, and every membrane is unique. Every cell type has a unique membrane. And the one metaphor I kind of use to help people understand what omega-3s do in membranes is to picture membranes having doors, an in-door and an exit door. And these are protein channels for us in the sciences that are opened and closed appropriately when they're needed to be. When you need to get a signal into the cell to do something, you will need to get food in the cell. There's a door that has to come open to bring the stuff in the cell. And if you think about those doors, think about the omega-3s being oils and lubricating those doors, the hinges on those doors, so that they open and close more appropriately. If you can't get the right nutrients in, the right signaling molecules into the cell at the appropriate time, the cell can't respond properly. It's not going to be healthy. If you can't take the trash out, which you need to do in a cell, you need to get rid of the trash, just like your house. There's a door for that. And if that hinge is stiff, you're going to keep the trash inside. That's not good for the cell. So the omega-3s really help optimize cell membrane function. It's a little bit of hand waving there, but that's kind of the general idea, that they do help at the membrane level. And that's not necessarily inflammation related thing. That's part of how they regulate the inflammatory response, is how they open and close these doors. But it basically is, why do cells just work better? Why do they live better? They don't have to. Cells live longer. I mean, when we look at the rate of telomere attrition or shrinking of the telomeres, we know that people who have the highest omega-3 levels have the slowest rate of loss of telomeres. So it means their cells are turning over less fast. They're living longer. which manifests in a longer lifespan for the whole organism. So
Earlier, when it came to pregnant women and fish, you added more nuance there. When it came to the blood thinning, again, there was more to that story. Before we part ways, any other nuance you want to add to different topics that come up in the omega-3 world, or myths you want to bust?
well, I mean, just this is a very minor thing, but it always comes to mind every time I see a picture of omega-3 rich foods on some website. They'll have a little salmon and sardine down here. They'll have a little black walnut over there. They'll have a little bowl of chia seeds. They'll have a little flask of flaxseed oil probably. And then they always have a nicely half-cut avocado sitting in the middle of that picture. There are 0 omega-3s in an avocado. Now, I don't know how avocados crowded their way into this picture, but it just always kills me that, who's thinking about this? Who's putting these things together? So there's a myth there that there's no omega. Avocados are fine. They're great, but they are not a source of omega-3. And all those pictures of omega-3 foods ought to be completely flooded with fish and not bother with, it's not all walnuts, it's black walnuts. So there's some nuance there. Other than that, golly, we've covered a tremendous waterfront here of fatty acids and health. And so nothing else really leaps to mind that I'm champing at the bit to correct here.
Okay, well, let's leave everybody with an action step. Somebody that wants to start heading up that continuum of the omega-3 index.
Yeah.
What's something they can do today to start working their way up?
They can measure their level.
That chain.
That's the first thing to do. Find out where you're at. Do a blood test. I mean, OmegaQuant is not the only company that tests omega-3 levels. We're the ones that do it in red cells, but other people do it in plasma. And I'll rejoice that anybody's doing any omega-3 testing. I'm happy with that. But find out what your status is. Find out where your level is, and then titrate. Start adding omega-3 to your blood, to your body, and until you get it up to that healthy level, and then keep it there. And that will, it will cover a multitude of sins once you've done that.
All right, Bill, really enjoyed the conversation. We're going to link up in the show notes how to get tested, your website, everything there for people to continue their research after this. Really enjoyed this. You are a true master in this realm. I appreciate you giving me 2 hours. This was a lot of fun. Thank you.
Thank you, Jesse. I really enjoyed it. You had great questions, some brand new ones I have never heard. I loved it.
Thanks for watching the episode. I got another great one lined up for you right here. Don't miss it. I'll see you over there.
Contrary to what it says in any source you look at, that inflammation is the immune system's first response to infection or injury, it is really only a first response to infection. Inflammation does the body